Hi guys, I'm going to do a couple of quick problem from section 6.4. First problem is number 13. This is actually a pretty quick one. So the question says to write write three other proportions following or from the following proportion. Okay, so they give us a proportion which says basically 12 cents over 36 ounces is equal to 16 cents over 48 ounces. Okay, so now first of all, it's called proportion. Anytime you have each of these, if you look at each side, these are called ratios, right? So you have a ratio, basically ratio, same thing as fraction, quotient, division, but in this respect we call it ratio. This is another ratio. So anytime you equate two ratios, that's known as proportion. So every proportion involves four parts: 1, 2, 3, 4. And of course, a lot of time in a lot of applications, as long as you have three of the parts known out of the four, you can always find the unknown one. And sometimes use this exactly for that reason, to try to find out, for example, if 36 ounce costs 12 cents, somebody may ask the question, how many cents would 56 ounce cost, right? So they can actually just set up a proportion solve and answer the question. But right now, they're already giving us a proportion, so just want us to rewrite it in three different ways. And this answers can vary because you can do it actually more than just three ways. So for example, one thing you have to be careful when you do have units involved, if you're going to write an equivalent proportion, you have to make sure the units always are in the same position. So if the cent is up here in this ratio, the cent must also be up here in this ratio. So you can have cent up here, and then on this side you have ounce up here, right? So right now, one option would be, so we can actually flip this. In other words, put the ounce upstairs and your cent downstairs. But again, remember, the cents must always go to the same place. So you also must put 16 cents down here and 48 ounces upstairs. So this would be one way to rewrite the same proportion. And they're equivalent. They pretty much say the same thing, it's just in different way. Or you can actually do the following. You can actually flip this, or I should say you can actually put the cents together. 12 cents over 16 cents. And that's the same thing as, basically, now the only thing you have to be careful, since 12 cents is associated with 36 ounce, so when you put the 12 cents up here, you must also put its associated ounce, the same position, which is in the numerator. And then over the 16, which goes with, of course, 48 ounces. Okay, so this is two ways already. Now I'm just going to erase, I guess, the original one. And the last one would be, I'm just going to flip this and put 16 over 12, except you would also have to flip that and make that 48 over 36. And that should be a third option. There's even more than these three options, but just to answer the question, the third option would be, again, just flipping this last one to put 16 cents over 12 cents. And that is the same thing as, but again, you also have to flip that, which becomes 48 ounces over 36 ounces. So these will be the three different ways that you can write the original proportion. Okay, I hope that helps. Let me see if I can go ahead and do also the last one, the one the student had a question about, the number 15. And that one also is pretty quick. It's two parts, A and B. So let me start with part A. Now that one actually, that problem 15, I believe, is going to actually use the same idea I just mentioned, how the proportion can help you to answer unknown or answer question and solve for unknown. So number 15, section 6.4, the number 15. Let me read the question. And in number 15, it says that gear ratios are used in industry. A gear ratio is the comparison of the number of teeth on two gears. When two gears are meshed, the revolutions per minute, by the way, the RPM, as you'll see throughout this problem, is short for revolution per minute, right? So in other words, how many revolution per minute does this gear will turn? When two gears are meshed, the revolutions per minute, RPM, are inversely proportional. So inversely means as one gets bigger, the other one gets smaller because they're inversely proportional. So, and of course, here's the relationship. So here's what we have. RPM of the large gear, over the RPM of the small gear is equal to the number of teeth on, that's why it's inversely, because now the small goes up here, a small gear, and then over the number of teeth, number of teeth in the large gear. Okay, so this is actually in your book. So this is the proportion that they give in the book. So the key to remember here, the RPM of the large over the RPM of the small is the same as number of teeth on the small. In other words, that's what they call them inversely proportional over the number of teeth of the large gear. So this time the number of RPM of large goes up here, but then the number of teeth of large goes down here. So this is a proportion, as I mentioned a minute ago, because you have equality between two ratios. So now, so anytime they give you a proportion, they give you three unknowns. So this is 1, 2, 3, 4 parts. As long as you know 3 out of 4, you can solve the unknown. So let's see what they give us in part A. Okay, I'm just going to quickly write down the information. It says the RPM ratio of the large gear to small. So large RPM of the large to a small, now it's given to be 4 to 6. Now this means, now don't forget, this is a notation for ratio, which means you have, remember, RPM of large over small. So that'll be 4 over the 6 equals, now we know it's going to be the number of teeth of the small over the large. So they're going to give you one of these, they want the other one. So let's see which one they give us. It says if the small gear has 18 teeth. So remember, a small goes up here, so therefore 18 goes up here, and they want to know how many teeth does the large one have. So this is, I'm going to call that X. That will be the number of teeth the large one has. So there it is. There is your beautiful proportion. You see, you have 3 parts. You only have one unknown. The easiest way to solve any proportion is to cross multiply and then solve for X. So from here, 4 times X is the same as 18 times 6. And then you divide by 4 to isolate X. And as you reduce your number, you should get, I did work it out for you, 27. So X should be 27. Okay? So there is the answer to part A. So that will be, so 27 will be the number of teeth your large gear must have based on our proportion. Part B is very similar, so I think we're going to use the same proportions. I'm just going to leave that there and then read part B. So part B says the large gear revolves at 200 RPM. So the large gear, remember the RPM of large gear goes upstairs, so that'll be 200 over. Has 60 teeth. Now remember the number of teeth of the large goes down here, so the bottom is 60. And then he says, how many teeth are there on the small gear? Remember the number of teeth of a small is up here, so I'm going to call that that's unknown X. So they better give us the number of the RPM of the small gear. It says, which has a RPM of 600. The small gear has RPM of 600. That's it. So once again, another proportion, only one unknown. Actually, in this case, it's very easier because the numbers are very nice. So if you just cancel 1 0 from 1 0 here, you can see, of course, that since 60 is the same as 60, of course, X must be 20. Or you can just cross multiply and solve that way. Either way, because since the bottoms are the same, the top must be the same, so 20 must be X or X must be 20. So in this case, the number of teeth of your small gear must be 20 teeth. Okay, I hope that helps.